because we have all these programs going on. The space station program is going strong. It's just starting to hit its stride. You know, we finished construction of the space station a few years back. Now we're just starting to learn how to operate the space station more and more efficiently every year. We're bringing in commercial companies to utilize space station. It's not just a bunch of government scientists using space station. We're using commercial companies. We're letting them go up there and test out their things, their experiments, new products, new materials. You got the commercialization of space. It's taking off, literally and figuratively. We got Orbital ATK building cargo ships. You got Sierra Nevada building cargo ships. You got Boeing and SpaceX building crewed ships that will fly here in 2 or 3 years. You got tourism to space with Virgin Galactic and Blue Origin, and there's just so many companies out there. It is amazing. It is amazing that anybody who wants to go to space who's alive today, you got a great opportunity ahead of you, I tell you, because there's going to be all kinds of craft leaving the Earth's planet here in the near future. And then you got Orion and SLS, and you're going to see all kinds of great hardware tomorrow about SLS and then Orion. But Orion is not just low Earth orbit. Orion's going beyond low Earth orbit. So what does that mean? Like, to a crew member, we talked a lot about the hardware. What does that mean to folks who are going to actually ride these vehicles? I've been on 3 space shuttle launches. I've flown on Atlantis, Endeavour, Discovery, and I've done a Soyuz launch. I've been to the International Space Station. I helped build the International Space Station. I lived on the International Space Station. All of that was going around the Earth the whole time. My space shuttle missions around the Earth. Space Station, 188 days going around the Earth. It was fantastic. The Earth is beautiful. But that's what everything we've done since 1972-ish, last lunar landing, has been low Earth orbit. It's time to go back. It's time for NASA to go beyond low Earth orbit. We're going to leave low Earth orbit to the space station. We're going to leave low Earth orbit to the commercial folks. Maybe they'll go further, but we're going to leave them here in low Earth orbit. And it's a time for NASA to push the envelope. And that's what NASA's all about. A lot of these companies cannot afford to go beyond low Earth orbit. They can barely afford to get to low Earth orbit. So we're going to blaze the trail. NASA has blazed that trail in low Earth orbit, and we're going to give it away, and now we're moving on. So imagine going beyond low Earth orbit, going around the moon. Some of these trajectories we have go, thousands of kilometers beyond the moon, where we're going to be orbiting in these different trajectories. We're still trying to figure out what the best trajectory to use is to go beyond low Earth orbit and circle the moon, or orbit the moon, as I was corrected by a 9-year-old one time. But it's not. This is not low Earth orbit. Is simple compared to going to the moon or to Mars. Because think of it, you're in your spacecraft, you're circling the Earth. Soyuz, one of the training things we learned in Soyuz is if the vehicle's on fire inside the cabin, you know what we did? We closed our visors and we evacuated all the atmosphere out of Soyuz. And nothing can survive in a vacuum, including fire, including crew members, but we were in these suits. We would evacuate all the air out, and we'd turn the vehicle around, fire or burn our engines, and come home, and we'd be home on the ground an hour and a half after. Anything goes wrong in low Earth orbit, the Earth is right there. Man, you fire an engine and come home, you can be home in an hour or 2 hours. Maybe worst case when you're docked to space station, it takes you a couple hours on dock and another hour to come home. But when you're circling the moon, or when you're going beyond low Earth orbit, you're 5 days from coming home. So imagine when something goes wrong, you have a fire, you have a leak in your atmospheric system, your ECLS, your environmental control system is not working. So things have to be much more robust, and that's what Orion's going to do. SLS is going to throw us up into low Earth orbit. The upper stages are going to push us beyond low Earth orbit, and then Orion is going to keep the crew safe. It's going to be a robust vehicle, allows us to take the crew to places where we haven't been in many, many years. So, like I said, it is an exciting time for NASA. The space station program going strong. We finished construction of the space station. Now we're learning how to utilize it. Commercial companies are starting to utilize the space station more and more. We're using the space station to test out the CO2 system for Orion. We're using it to test out the toilet that's going to be on Orion. If you don't think that's important, it is, trust me. So there's a lot of things going on space station. Then you have commercial crew and commercial cargo and commercial space exploration. You've got SpaceX and Boeing building crewed vehicles that are going to go up to the space station and beyond. You got Sierra Nevada, Orbital ATK building cargo vehicles. You've got other companies that are trying to do space tourism, Bigelow and Virgin Galactic and Blue Origin, and just so many other companies are involved in the commercialization of space. And then of course you got come back to NASA with Orion and SLS. SLS is going to be the most powerful rocket ever built when it's all done several years from now. It's going to have to throw up all this hardware into low Earth orbit, so then we can then take it to the moon and beyond, all the way to Mars. The exploration upper stage being built also at Marshall and tested and assembled in Michoud and Stennis. That's going to take the Orion vehicle and push it beyond low Earth orbit to go to these trajectories to moon and Mars and beyond. And then, of course, Orion at the Johnson Space Center. Glenn is working with us also. European Space Agency is building part of the Orion. So there's so many NASA facilities, there's so many contractors, so many folks involved. It's a very exciting time. It's an exciting time. We've got all these engineers back here. It's an exciting time for them. A lot of them are a little bit younger than me, a lot younger than me maybe. And it's a great time to be there. It's here at NASA working in aerospace. It's a great time to be an engineering student because we have so much work to do. And it's a team effort. You know, as an astronaut, we get to ride on these rockets, we get to fly in these missions, but it's really a team effort. There are so many folks that it takes to do these missions, as you can imagine, and we're going to learn more about that. So, but to a crew member, you know, all my missions, I've done several shuttle missions, I've done a Soyuz, I've lived on space station, and all my missions were in low Earth orbit, where we had close support by the ground folks. When we had to change out a light bulb, we asked the ground's permission. When we had something break, we asked the ground for repairs. Every time we had to do something, we talked to the ground. I could phone home every day. The time delay was only a few seconds. We're going to have to change the way we do business. When we go beyond low Earth orbit, it's going to be days, weeks, months, even years before we can get back home. So the crew's going to have to be much more independent. We're going to have to have things like additive manufacturing or 3D printing. We're going to have a lot smarter vehicles, and we're going to have a lot smarter crew members too.